So let's get some context of radical functions and how they relate to power functions. So our function that is the square root, we could rewrite that as a power. F of x equals x to the 1/2 power. So with that rational exponent, we could think of this as a power function. This also relates to our parabola as the inverse, but really it's only half of the inverse. To have the other half, our graph would have to do like this, and that's no longer a function because it would fail the vertical line test. So instead we just have that top half. But it does relate to a parabola and the properties that we talked about of like 1, 1, 2, 4, 3, 9, so on and so forth. But it's just going in the other direction because our x and y coordinates have swapped here. Okay, so for domain, we're going to focus on where this point kind of begins our square root function. So in its initial form, it's at the origin. So our domain would start at 0 and then go off to infinity, and the range would be the same. And that would just adjust based on any horizontal or vertical shifts that we have with our function. Similar idea here with our cube root function. This could also be described as f of x equals x to the 1/3. And now this is a good translation of our inverse function, of our x and y values switched from our cubic function, so that now it's on its side and it still is a function. So it's because the cubic function's 1-to-1 that we can make this inverse. It works great. However, our parabola is not 1-to-1, so that's where we only end up with half of our graph. Domain should be all real numbers, and range should be all real numbers with these. No matter the transformations we make, that should hold true. Okay, so let's talk about making graphs here. So, some pieces here. First, recognizing that we're taking the cube root here. So again, thinking about a parent function. So what is the function at the beginning of everything? And we're thinking about that cube root function. But then we have 3 transformations. So with that 3 out front, we have a vertical stretch by 3. With that negative in there, we are going to reflect over the y-axis. And then with that 4 right there, we have a horizontal compression by 1/4. Sorry. There we go. Okay, so if I think about my standard cubic function, so we'd have 0, 0, and then I just kind of think about the cubic function to make the cube root function of like 1, 1, 2, 8, 2, 4, 6, 8, 3, 27. If I just flip my x and y coordinates of how I would usually write the cubic function, which would look like this, I've now just turned it on its side by switching x and y. Same thing down below, down 1, left 1, down 2, left 8. Okay, so let's go ahead and do vertical stretch by 3. So 1 is now going to be a distance of 3, 2 is now going to be a distance of 6, 0, 0 stays put, 1 will now have a vertical distance of 3, and 2 will now have a vertical distance of 6. Okay, so that stretched our function upward. Let's go ahead and reflect over y. So I would bring us over here, and let's see, that would be a 8, 6 down here. So reflecting over. Okay, and our last piece is going to be a horizontal compression by 1/4. So where I have this horizontal distance of 1 here, we're going to squish into a 1/4. And then where I have this distance of 8, cut that by a fourth, and now we're at a 2. And same thing down here. Oh, this is going to be squished, but we can grab it. Okay, so our function is going to do something like this. Okay. All right, so following our cube root function along with those transformations. Let's check out this next one here. So for this one, our parent function is going to be our square root function. So our basic setup for that one will be 0, 0, 1, 1. If we plug in 4, the square root of 4 is 2. If we plug in 9, square root of 9 is 3. Okay, then two pieces we have here. We have a horizontal stretch by 3. And we are going to have a vertical shift down by 2. Okay, so horizontal stretch by 3. So where I have this distance of 1, now I would have a distance of 3. Where I have this distance of 4, now I would have this distance of 12, which kind of goes off the page here, but I'll just kind of mark that. And that top one I won't even be able to see. So horizontal stretch really lengthens things out, and then we're going to bump down by 2. So we'll be down here, here, and a little bit off the page right there. And then we connect them with something that kind of feels like a parabola, but it's on its side, like that, with some curvature to it. And there we go. So we're going to talk about radical functions more later on, but this is just kind of an overview as related to power functions and following our graph transformation.